at 75 and Loop 12 has traffic backed up to downtown, and you can expect heavier than usual delays eastbound on 635. They're closing up the HOV lane on I-30 as things get back to normal, and that'll about wrap it up for another afternoon rush hour. Interstate 30, the East R.L. Thornton Freeway, is a major 8-lane radial artery located in Dallas, Texas. Like so many of our nation's freeways, I-30 is forced to carry many times the number of cars that it was designed to handle. During peak periods, about 65% of the freeway's 31,000 vehicles are traveling in the same direction. This has led to average vehicle speeds below 30 miles per hour during both peak periods.
As early as the 1970s, the Texas Department of Transportation in the Dallas area determined that there was a significant need for some congestion relief in the I-30 corridor. The uniqueness of the imbalance in the peak direction traffic caused us to look immediately at the existing contraflow lane technology. At that time, the technology had not been developed sufficiently, and only the pylon technology was available to us. We did not feel, for safety reasons, that it was an applicable technology in this corridor.
The Quickchange Movable Barrier, or QMB, developed by Barrier Systems Incorporated, proved to be the solution to this complex problem. Movable barriers were placed on either side of the existing median barrier. To accommodate peak hour traffic, one row of barriers is moved across the shoulder and a travel lane to create a protected corridor to be used by contraflow traffic. Buses, vans, and other high-occupancy vehicles can access this newly created lane at various points to speed them on their way. After the rush hour is over, the movable barriers are shifted back to the median, and normal road configuration and capacity is restored. 8.5 miles of barrier weighing 20 million pounds is moved twice a day by the transfer vehicles. The average move takes approximately 66 minutes. 1 meter long safety-shaped concrete barriers are connected by heavy steel pins and hinges to form a continuous wall. The transport vehicle uses the principle of a simple inclined plane to move the wall across the roadway. As the machine moves forward, the barriers ride up the conveyor, which consists of horizontally opposed inverted wheels. These wheels lift the barrier sections by the underside of the T-shaped top. The transport vehicle actually lifts the barriers up off of the roadway. At no point during the process are the barriers dragged across the roadway surface. The barriers are transported through an S-shaped conveyor system from one side of the vehicle to the other. In order to form a breakdown shoulder along with the HOV lane, the vehicle was required to transfer the barrier laterally anywhere from 11 to 22 feet. The vehicle is steered automatically by a computerized guidance system that reads a signal coming from a cable buried in the roadway. This unique steering system allows the vehicle to rotate around its axis, crabbing the vehicle, effectively increasing or decreasing the width of the transfer. This innovation allows for total flexibility in lateral barrier movement and ensures accurate placement each time the barrier is transferred. The Dallas installation presented other unique challenges to the barrier system's design team. The inside shoulder of the road had variable width, which meant that the distance of transfer was not constant. This means that the length of barrier needed was different in the deployed and stored positions. The solution was to strategically place specially designed hydraulic metal barriers that would expand and contract. Another problem was that the shoulder is a different slope from the main lanes, and a curb in some areas necessitated vertical height adjustment during the transfer. Specially designed hydraulic struts were installed on the transfer vehicles. These struts allowed the height of the vehicle to be adjusted up to 15 inches independently at each wheel, enabling the machine to make the variable vertical lifts.
We had some unique design concerns in this corridor. and Barrier Systems was able to meet those design concerns and continues to give us support, both ourselves and Dallas Area Rapid Transit, in the continuation of this project.
Another benefit of the movable barrier design was the ease of enforcement. By creating limited access points, minimal enforcement personnel are required. A concurrent flow lane on the inside shoulder of the access point gives the enforcement officer ample time to screen the entering vehicles and divert violators back into the general purpose lanes.
The HOV lane has proven to be very successful. We're seeing speeds of 50 miles per hour in the HOV lane as opposed to speeds of 25 miles per hour in the adjacent main lanes. We're also seeing travel time savings of 8 minutes in the morning and approximately 4 minutes in the evening compared to travel times before the HOV lane opened up.
In addition to the increased speed, bus ridership is up 8%. Carpools have increased by 200% during both peak periods. The HOV lane is carrying more people in the peak hour than 2 freeway main lanes. Total person movement in the corridor has increased almost 60% in the morning and 30% in the evening. The I-30 HOV lane was the first of its kind in the United States. The tremendous success of the project has generated interest from highway departments around the country and continued enthusiasm from Dallas area commuters.
Public support for this project has been overwhelming. Because we decided to use the Quickchange movable barrier system, we were able to open up the lane for usage by both van pools, car pools, and buses. Therefore, more people are able to see the benefits and utilize the benefits of this lane on a regular basis.
Not only can the QMB be used to form HOV lanes, but it may also be used to increase the capacity of other roadway structures such as bridges and tunnels. These natural choke points are a major cause of recurring congestion. The QMB can give these facilities dynamic capacity, the ability to change to meet the uneven demands of traffic during the course of a day. When used as a median divider, movable barriers can be quickly and safely moved to change the number of lanes available to traffic. Permanent systems of this type are being used on bridges around the world. These systems are increasing carrying capacity at a fraction of the cost of building additional lanes. The Quickchange movable barrier is a revolutionary new tool that is increasing the effective capacity of our nation's congested highways. Whether for HOV facilities, reversible lanes, or the reconstruction of our highway system, Barrier Systems Incorporated is leading the way to innovative transportation solutions.